Greetings everyone. Today we're going to explore the quadratic formula. Consider everything we've learned so far, factoring, using square roots, and yesterday completing the square. Knowing completing the square and the steps that it has, and with those steps being very repetitive, you can turn that repetitive process into a formula. When we transform that repetitive process into a formula, we get the quadratic formula. Add this to your notes, write it nice and big and clear because you're going to use this formula over and over. The purpose of using it over and over is so that it makes it easier to remember. We want this repetitive process to turn into a quick process through using the formula. If we take the piece under the square root out, we end up with the discriminant. Let's discuss the discriminant. The discriminant tells me if I'm going to have a real, imaginary, or a rational value. Think about it. If I end up with a discriminant that's equal to 5, that would look like square root of 5. That's an irrational answer. If the discriminant, or what's underneath the radical, ends up being a negative 5, we would end up with an imaginary answer. Or if the discriminant ends up being 16, that would give us 4 and therefore a real answer. So the discriminant can tell us a lot about where we're going for our solutions. Now remember, if a quadratic is not factorable, we have the option of completing the square or quadratic formula. I am going to have the expectation of both on the test. But know that you can actually use completing the square and quadratic formula for every quadratic. Meaning, if you have an x squared, an x, and a constant equal to 0, you can always use quadratic formula or completing the square to solve. Sometimes we get messy answers, sometimes we'll end up with clean answers. But they'll all give us a solution of x equals. In the past, I've noticed that some students really connect with completing the square and others really connect with quadratic formula. It depends on your style of learning. So definitely try to stick to the one that makes more sense to you, but again, I will ask you for both on the test. Let's take and apply the formula. First thing is to make sure it's in standard form, meaning x squared, x constant. Make sure that it's equal to 0, meaning everything's moved to one side. Let's identify our a, our b, and our c. The a is 1, the b is 2, the c is negative 8. You want to keep the signs that go with the number. So when I plug it into the formula, x equals a negative, my b value is 2. I have plus or minus the square root of b value squared minus a 4 times an a times a c. My a value is 1, my c value is negative 8. All over 2 times a, and our a value is 1. Now I want to work on reducing this. The negative will now stay with the 2. Positive 2 squared is 4. Here, if I break this apart, it's like I have a negative 4 times a 1 times a negative 8. A negative times a positive times a negative gives me a positive. 4 times 1 times 8 gives me 32. So I end up with a positive 32. Still all over 2. Let's keep reducing what's underneath the radical. We end up with 36 all over 2. Square root of 36 in this case is actually a perfect square, plus or minus 6. Now in this example, we ended up with nice numbers, meaning no radicals, no imaginaries. So I can actually separate this into two equations. I have the negative 2 plus 6 over 2, and I have the negative 2 minus 6 over 2. If I solve that, I end up with 4 over 2 and negative 8 over 2. So x equals 2 and negative 4. Those are my solutions to this quadratic. Now remember, if you end up with nice solutions, that actually means that this was factorable. We could have used AC method. So if you're unsure, you could use AC method to confirm that we end up at 2 and negative 4. Let's take a look at another example. Let's start off by identifying our A is 1, our B is negative 6, our C is 7. Let's plug it into our formula. A negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Now notice out front, I have a negative from the formula and I have a negative from the value of B. Subtracting a negative or double negatives become positive. So again, a negative and a negative becomes positive. We've got our plus or minus. Negative 6 squared is positive 36. A negative times a negative is positive. And then here, I have a negative 4 times a 1 times a 7. A negative times a positive times a negative gives me a negative. 4 times 7 gives me 28. All over 2 times 1. Let's keep reducing the right side under the radical. 36 minus 28 gives me 8. All over 2. Square root of 8 reduces. So I have to break that apart. So square root of 8 has a good and a bad of 4 and 2. Square root of 4 is 2. Square root of 2 stays square root of 2. So now I have 6 plus or minus 2 radical 2 over 2. I reduce the radical, but I've got a lot of even numbers on this case. So I'm actually going to separate this fraction out and see what it looks like. By separating it out, it becomes clear to me that each fraction can reduce, meaning the whole numbers, no radicals included, reduce down. So I end up with a 3 plus or minus a 1 radical 2. Now I don't need the 1 out front. If you put it there, that's okay. But in the end, this is my final solution. Let's approach one more example. You'll notice in this one that I don't have it equal to 0, and I have my terms mixed up. So my first goal is to move everything to the one side and write it in standard form. So I'm going to start off by adding 2x and adding 7 to the left side. That leaves me with an x squared, a 2x, and a plus 7. Now it's all equal to 0. A little side note, if we would have moved the x squared to the right side, we would have ended up with a negative leading coefficient, meaning a negative in front of the x squared. That makes things really messy. So we want to avoid that being negative. So if you move it to the right side, then I would take one more step, divide everything by negative 1. Then we end up with a x squared plus 2x plus 7. Keep that leading coefficient positive. All right, let's continue by identifying our A value, which is 1, our B value is 2, and our C value is 7. Let's plug it into our formula. Negative B plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Let's reduce what's under the radical. I have a negative 2 out front. 2 squared is 4. If I look at what's under the radical, I have a negative 4 times a 1 times a 7. I'll know I'll end up with a negative answer, and 4 times 7 gives me 28. So I'm going to subtract 28 all over 2. Let's keep reducing what's under the radical. 4 minus 28 is negative 24. We've got a negative under the radical, which means I need to take that negative out and make it an I. So now I have an imaginary number. I also need to reduce square root of 24. Square root of 24 reduces down to a good and bad of 4 and 6. Square root of 4 equals 2. 6 is bad or not a perfect square. So if I rewrite, I now have negative 2 plus or minus 2i radical 6 over 2. So I replaced that radical 24 with the 2 radical 6. Now if I take a look, both of these fractions reduce. So my final answer is x equals negative 1 because of negative 2 divided by 2, plus or minus 2 divided by 2 is 1, an I, and a radical 6. If you don't include that second one, that's okay. This becomes our final solution. For homework, make sure you check out Google Classroom for your worksheet or assignment. And also, make it a point to find some way to start remembering the quadratic formula. Whatever it takes, maybe writing it multiple times every time you do a problem, listen to a song, repeating it out loud, but find some way to have that formula memorized. If you have any questions or need any help, make sure you ask. We'll see you next time.